Hello everyone. We are just going to get started on the notes today and just do one example, and then we'll finish up on Friday. So this is still part of section 6.2. It's called determining normality. So a lot of our problems so far, you've noticed, it said assume the variables are normally distributed. Well, here we could actually conduct several tests, and it's usually the analysis of all of these tests combined that can confirm that our data is normally distributed. So if you recall, a bell-shaped distribution is one of many shapes. So there's several ways, and in the past we've also kind of checked to see the shape of our distribution. So several ways to check for normality. So the first is to draw a histogram and check its shape. We're going to do everything on a calculator though. Second is we can kind of see the skewness of the graph. It's called, or also referred to as the Pearson coefficient of skewness, or PC, and it's just a little formula here. That the Pearson coefficient is equal to 3 times the quantity of the mean minus the median over the standard deviation. So if the result is greater than or equal to 1, or less than or equal to -1, we can conclude that the data are significantly skewed. Go ahead and pause the video if you need more time to write that down. There's a total of 4 ways we're going to check for normality. So these were the first 2. To construct a histogram on your calculator, check its shape, and run this little test using the formula for skewness. The third is to check for outliers, as we have done so in the past. These values can have a big effect on normality. So remember, first we want to find the interquartile range, which is Q3 minus Q1. And if you recall, if we just entered a list in spreadsheets, if we just typed in a list on our calculators and we ran the data statistics, it gave us these values. So again, we don't have to do all of this by hand anymore. We did at the beginning, but now we don't. And if you recall, to calculate the boundaries, the lower boundary is Q1 minus 1.5 times the interquartile range, and the upper boundary is Q3 plus 1.5 times the interquartile range. And then this fourth type is called a normal quantile plot. The computer software, we could use computer software to help us calculate this, but again, since we've been doing everything on our Inspire, I'm going to show you how to construct one on your calculator. And how we analyze this is if the points of the quantile plot do not lie in approximately straight line, then the normality can be rejected. So we're either going to say we can accept normality, or the variables are approximately normally distributed, or we say we reject normality. And again, pause the video if you still need to write this down, and then get your calculators ready. All right, so we're just going to go through this example, and we'll do another example on Friday, being that your quiz is tomorrow. So this deals with technology inventories. A survey of 18 high-tech firms showed the number of days inventory they had on hand. Determine if the data are approximately normally distributed. So what you want to do is start a new document on your calculator. You want to go to not the calculator page, but you want to go to 4, List and Spreadsheets. Now remember, at the top of your first column where it says A, all the way at the top, you should have an X, and then you skip a space, and then just going straight down, you can type in the data values 5, 29, 34. So these should all be in the first column, all the way down to 158. And then remember, when you're done typing them in, you want to be in a cell that's empty. So just hit down one more time after you're done typing in that 158. It's always good to double check too once you have the list made. All right, so pause the video if you still need more time to type these in. So the first thing we're going to do is construct a histogram. So what you want to do when you're done typing all this in is hit Control Doc. We want to go to 5, Add Data and Statistics. So again, once you're done typing this in, make sure you're in a block, an empty cell right below the 158, hit Control Doc and go to 5, Add Data and Statistics. Then you want to hit Tab, and you should see the X show up at the bottom of your screen. Just hit Enter, and all the points kind of get moved to the bottom there. Then go to Menu, Plot Type 1, and we want to go down to number 3, Histogram. And it should construct a histogram that looks like this. So what we're analyzing here is we do have a peak in the middle. It doesn't seem to be skewed anyway. So technically we could kind of say it has somewhat of a bell shape, so it doesn't look drastically skewed. So it appears to be bell-shaped. This is why we need more than one way to kind of clarify this or come to our conclusion. All right, so the second thing we want to do is calculate the Pearson coefficient. So if you recall, that's 3 times the quantity of our mean minus our median divided by our standard deviation. Well, we could find all of this on our calculator. So if you just hit Control and the left arrow on your mouse pad, it should take you back to the other tab, or you should just be able to use your mouse pad to slide up and hit the tab that's up there. All right, so what we want to do here, now we should be in that list and spreadsheet page. Go to Menu, go to 4 Statistics, go to 1 Stat Calculations, and then 1 Variable Statistics. Number of lists should just be 1 and hit OK. Everything here, X1 list is A, frequency list is 1, and then first result column at the bottom there is B, and just hit OK. And then you just have to scroll up. What we're looking for is the median. So the median should be 77.5. The mean, we should see X bar, go all the way up, should be 79.5. And we have to go back down where we see SX should be about a 40.5. And then we'll just use this formula here. So this is 3 times 79.5 minus 77.5 over 40.5. And go ahead and calculate that. We should be getting a 0.15. We want to compare this to a positive one or a negative one. It's definitely positive, but it's small compared to 1. So from this conclusion, or from this result here, we can add to the conclusion that we kind of came up with for the first way to test this, that we could say the data are not significantly skewed. All right, the third way we're going to test this is to test for outliers. So we need to find Q3. So in our list here, we need Q1, we need Q3. So we want to test for outliers. So if you notice, Q1 should be 45. Q3 should be 98. That means the inner quartile range is 98 minus 45, which should give us 53. So to come up with our lower boundary, that's going to be Q1, so 45 minus 1.5 times 53. And we know this is going to give us a negative number, and we didn't have any negative values. But go ahead and calculate that. We should be getting a negative 34.5. So I don't have to worry again. All of our values were positive, so we don't have any outliers coming from being below this number here. The upper boundary, we're going to take the 98 plus 1.5 times 53. And we should be getting 177.5. So remember, our largest value was 158, so we have no outliers. So therefore, symbol for therefore, we would say no outliers. And this adds to support our answer here that the data is approximately normally distributed. And we'll do this one more time using a normal quantile plot. So again, we're going to go back to Control Doc to create a new page. Go to 5, hit Tab again, and then the X should show up along the bottom, and hit Enter, so all the dots are going to the bottom. But now when we go to Menu, just the same way we constructed a histogram, go to Plot Type. Now notice right under histogram, option 4 is normal probability plot. That's the same thing here, a normal quantile plot. So go ahead and select that. And it draws in what's considered, if you guys have heard of a line of best fit, and then it plots the points with respect to this line here. So we should be getting something that looks like this. Now just about every point is super close to the line, so again, we can make this conclusion. The data appear to be approximately normally distributed. So again, this was just one example taking us through the 4 ways of determining normality. So there's no new assignment today. If you still need to finish up the applying the concepts, please do so, as well as prepare for the quiz tomorrow. Let me know if you guys have any questions.